What is up, YouTube? So recently we've been discussing various API architectural styles such as REST, GraphQL, gRPC. Now let's discuss the major differences between these styles, and we'll also talk about each of their specific use cases. So let's get into it. So let's start with REST APIs. REST defines a set of constraints that every API conforming to the REST style should follow, such as being able to have client-server communication, being able to cache responses, it having stateless behavior, being able to have a uniform interface, it being able to have a layered system, and also being able to provide code on demand. If you're still a little bit confused about this, you can check out this video, which we go over all these different constraints for REST. And all HTTP methods can be used in a REST API call and perform CRUD operations. So REST has post, get, put, and delete. So let's talk about when REST can be useful. So REST APIs turn out to be a more suitable option in the following cases. So firstly, when we want to perform CRUD operations on resources, so REST is a resource-oriented style, and it's used to perform CRUD operations on data sources. And secondly, when we want stateless behavior, so when we need to maintain a stateless behavior in our request and response paradigm, for example, if the servers don't need to store any data from the prior requests to execute the current request, so the data in our current request should be enough to execute it successfully. There's also when we want to target a couple of resources or endpoints at a time. So if we have a few resources or endpoints to target, then REST could be a good option. But if we're targeting a lot of different resources or endpoints, then GraphQL could be a more suitable choice. And also when we want to use it as a wrapper. So say we have a backend gRPC service and we want to expose that data to other third parties, then REST becomes a really good accessible wrapper for that. And also flexibility. So REST provides a lot of flexibility due to its lesser burden on the server than GraphQL. So what are some factors that can be used to decide if REST is useful? So firstly, is the API public facing? Do we need to use it through native applications or via browsers? So if this was like a really internal backend service, then gRPC is still a good idea. But if you're trying to expose these endpoints to third parties, then REST is a lot more accessible. Are the expertise and costs to opt for REST, GraphQL, or gRPC feasible, or is it better to choose one with no expertise? In the case of using third-party services, is the opted architecture compatible, or do we need to bear the translation cost? So when should REST be avoided? So the heavy event-driven paradigm is getting popular in today's world. Some use cases that are bound to be operated asynchronously can be modeled via REST APIs, but there's room for improvement that can be optimized through asynchronous protocols. And there is a large amount of data in the big data processing and analytics world, so there are use cases where we need to connect applications and services with large-scale data, and data processing and communication between applications creates a bottleneck, and it becomes impractical when handled with a message-oriented RESTful interface. And, APIs are just a conduit to data, but they need to be an efficient facilitator to achieve application objectives. So if we're looking at this, when can we use REST for CRUD operations, for stateless behavior? We can use it as a wrapper. We can use it to collect data from a few resources. We can use it to achieve flexibility, but we should avoid it in event-driven systems, and we should also avoid it in big data processing and analytics systems. Now let's talk about GraphQL. So Facebook engineers developed GraphQL to handle the issue of loading data of different API requests from different endpoints to provide a rendered view. So for example, generating a news feed by fetching data from various resources through different API calls. And the REST APIs expose data through different endpoints, and GraphQL exposes data via a single endpoint, which is flexible. And GraphQL enables consumers to select and retrieve the required data from the API and get what they've asked for. So GraphQL enables us to see the data through specific schema, and this helps to read and write data in a structured way. So when can GraphQL be useful? So the following two use cases are where GraphQL is beneficial. So firstly, when there is a client application gathering data from multiple data sources, so GraphQL aggregates data from multiple data sources and sends a consolidated response to the client. So for example, in the case of a Stripe payment gateway, the data is retrieved from various endpoints, including customers, invoices, charges, and so on. And secondly, when many client applications share one data source, but their view is different. So GraphQL allows the applications to access the shared data where they can use it in a way that makes sense to them. So with GraphQL, applications can ask for the specific fields that they want to present to the user instead of requesting all the fields. So when should GraphQL be avoided? GraphQL is not the right option for server-to-server communication. So if we want to build a way for some backend services to speak to each other, GraphQL might not be the best choice here. GraphQL can be used for server-to-server communication, but there are certain drawbacks associated with it, such as the following. There's parsing and validating queries, which adds extra overhead compared to a simple REST API. Server-to-server communication may involve simple data communication, but GraphQL increases the complexity of implementing it. And GraphQL promotes strong coupling, so a server acting as the client will need to implement the exact structure provided by the server. And the performance of a server can be compromised when multiple services are involved and query different data. And GraphQL for server-to-server communication relies on factors such as the requirements, the complexity level, performance considerations, and trade-offs associated with that communication. So looking at this picture, when should we use GraphQL? When an application is requesting data from multiple sources, or when multiple applications share a single data source, and we should avoid GraphQL in server-to-server communication. Now let's discuss gRPC. So the gRPC API framework combines all the performance improvement and capabilities of HTTP version 2 as a single package. It can be utilized in several cases that require high throughput backends to communicate with limited CPU and memory devices. gRPC is a framework with built-in features required to run a system and efficient serialization and deserialization capabilities. So when can gRPC be useful? If we need a low latency, highly scalable distributed system, we should consider gRPC. By default, we can consider the protocol buffers, protobufs, as a better serialization mechanism. gRPC is also a better choice if we aim to build a backend system, including an enormous number of interconnected microservices. gRPC can provide efficiency and speed. gRPC also offers built-in features such as deadline propagation, cascading cancellation, retries, request hedging, etc. So when should gRPC be avoided? The gRPC framework supports only a few languages. We can't utilize it if our language isn't in the supported language list, and even if our language is supported, the consumer might want to use another language that is not on the list. If an enormous number of consumers are not able to utilize the native gRPC libraries, then it isn't a useful tool to use in this case. If we're building a system that calls a limited number of backend services and only communicates with a web browser, then gRPC is not the right option. So based on this picture, when should we use gRPC? We should use it to build low latency, highly scalable distributed systems. We should also use it to create a system having a large number of backend services, but we should avoid it when the developer's or consumer's language is not supported, And we should also avoid it in applications if they're calling a limited number of backend services. So let's do a quick comparison of the different API frameworks. So firstly, REST. We should use it when performing CRUD operations on resources. We should use REST to achieve stateless behavior when fetching data from a couple of resources. And we should also use it as a wrapper around other frameworks. But we should avoid REST in the event-driven systems, and we should also avoid it in big data processing and analytics systems. Then we have GraphQL. We should use GraphQL when an application is gathering data from multiple data sources or when multiple applications share a single data source. And we should avoid GraphQL in server-to-server communication. And lastly, we have gRPC, and we should use it when building low latency, highly scalable distributed systems. And we should also use it to create backend systems with a large number of microservices. But we should avoid gRPC if the developers or consumers language is not supported by the framework, and we should also avoid it in applications if they're calling a limited number of backend services. Now let's summarize what we learned. We compared the three main architecture styles, REST, GraphQL, and gRPC. We discussed when we could opt for one style over the others. Thanks so much for watching, bro. I really enjoy making these videos and hopefully you learned something. Leave a comment if you think I should update the way I'm presenting this information, and also leave a like and subscribe. It really means a lot to me, and I'll see you in the next one.